Okay, so this is the front of the first page on the 5.4 worksheet packet. This is a problem off an old AP calculus exam. It says the graph of a function f consists of a semicircle and two line segments as shown above. So this is the graph of f of x. So y equals f of x, in other words. Let g be the function given by, I'm going to write this so you can see a little better, g of x equals the integral from 0 to x f of t dt. Part A, find g of 3. So g of 3 means take the integral from 0 to 3. I'm just putting a 3 in for my x. f of t dt. Okay, so how would I find that integral using this picture? How do you find integrals with graphs? We just went over one. Area. Area between the curve and the x-axis. Okay? So, integral between 0 and 3. So let's find the integral from 0 to 2 first, which would be that quarter of a circle right there. And then let's also find the area between 2 and 3, which would be this little triangle down here, and then we'll combine them to get our answer. So let's see, area of a circle is, what's the formula for area of a circle? Pi r squared. What's the radius? If this was a complete circle all the way around, what would be the radius? 2. So pi times 2 squared would be 4 pi, but we only want a quarter of the circle. So what's a fourth of 4 pi? Pi, yep. So that area right there is pi. Again, I just did the area of the total circle was 4 pi divided by 4 because it's a fourth of a circle. So this first answer is going to be pi for that's the integral from 0 to 2. Now let's look at the integral from 2 to 3. Let's see, it's 1 unit wide and 1 unit high, this triangle. It's 1 by 1. So what would be the area of that little triangle right there? Yep, 1 times 1 would be 1, divided by 2 would be a half, so, or 0.5. So, and should I add or subtract that since it's below the x-axis? Subtract it. Or add a negative 1/2. Either way, I'm going to do minus a half. So there's g of 3. Pi minus a half. If we had a calculator, we could get a decimal, but otherwise we can just leave it like that. Any questions about part A? Part B, find all values of x on the open interval -2 to 5 at which g has a relative maximum. Justify your answer. Okay, to do that, I'm going to do part B down here a little bit lower. Let's think about the derivative of g. Let's do g prime of x. So we'll do the derivative on the left, and I'll get g prime. The derivative on the right, I'm going to use my derivative operator. It looks like this, d over dx. Okay, and if I do the derivative on the right side, what's going to happen to the derivative and the integral symbols? Cancel. What should I do with the x? Put it in for t, so you're going to have f of x times the derivative of t, which would be the derivative of x, which would just be 1. So basically what I just figured out is that g prime equals f of x. So this graph up here, the y-coordinate not only equals f of x, it'll also give me my g prime. It gives me both. F is equal to g prime. And if I want to know when g has a relative maximum, now notice that this is not a graph of g, this is a graph of f, or g prime. So you can't just look at this and say, oh, there's a maximum at 2 right there, of 2. You can't, it's not that easy. You need to try to sketch a graph of g. So what we're going to do is make a number line chart for g prime. It's going to go from -2 to 5. And to see g prime, I'm just going to look at my y-coordinate, because that's what it says up here. My y-coordinate's equal to g prime. So at -2, actually we don't need to do the endpoints because it has curved brackets on the in the problem. So let's just look between -2 and 2. Is the y-coordinate positive or negative between -2 and 2? Positive. So that means my g prime is positive. at 2. What's the y-coordinate at 2? 0. So g prime is 0. How about from 2 to 4, what's the y-coordinate? Negative. That means g prime is negative. At 4, the y-coordinate's 0. And from 4 to 5, the y-coordinate's what? Positive. So g prime is positive. Make sure you label your number line if you're going to use a number line like this. Now I'm going to try to make a sketch of g of x. So if g prime is positive, what's that tell me about g of x? Increasing or decreasing? Increasing. Yep, the graph's going to increase. It's going to hit a slope of 0. The negative first derivative means it's going to decrease, hit a slope of 0, and then increase again. Something like that. Okay? It did say we don't have to include the endpoints on the problem. So for part B, find all values of x on the open interval negative 2 to 5, where g has a relative maximum. So where does it look like g has a relative maximum?
2.
Right, x equal 2. Now it says justify your answer. I'm kind of picky on how you do that. The way I'm going to want you to say that is g prime switches from positive to negative. That's the best way to explain that. If g prime switches from positive to negative, that means g goes from increasing to decreasing, and there has to be a maximum at x equal 2. Any questions about that one? Okay, part C. Write an equation for the line tangent to the graph of g at 3. Okay, well here's 3 about right in here. I got to write an equation of a tangent line at the point 3 something right there. Okay, so to write an equation of a tangent line, you might remember that we usually use this equation. This is part C. Y minus y sub 1 equals m times x minus x sub 1. Point slope form of a linear equation. Well, say I want to know the slope right there. So I want to know what g prime equals, the slope at 3. So I want to know g prime of 3. That would tell me the slope right at that point. Do I know g prime of 3? Well, g prime of 3 would be the same as f of 3, because they're equal, right? Here's 3. What's f of 3? Negative 1. There's your, if you plug 3 in to your f equation, you get negative 1 for the y right there. So that's your slope. Again, if you want the slope of g, you have to do g prime of 3. If you want the slope of g at 3, you have to do g prime of 3, which happens to equal f of 3, which happens to equal negative 1. And these two being equal, that'll be a real common thing you'll see on a lot of these problems. Okay, on the right side, you're going to have x minus, what would you plug in for your x sub 1? 3. Good, because they tell you that in the problem. And on the left side, you're going to have y minus, to get your y prime, we're using the g graph, you're going to have to find g of 3. You're going to have to plug 3 into your equation. Well, didn't we already do that right here? Didn't we already find g of 3 in part A? Get pi minus a half. That's what goes right in here, pi minus a half. And that's your answer. That's your equation of your tangent line. You don't need to simplify it necessarily. You can leave it like that. Yeah, this may not be any easier than 55. There's a lot going on in 4 little questions here. Any questions? All right, let's finish off the last part. Part D. Find the x-coordinate of each point of inflection of the graph of g. So we're going to look for points of inflection on the graph of g on the open interval negative 2 to 5. So again, it's curved brackets. We do not have to include the endpoints. We have to justify our answer. So if we want to look for points of inflections on the graph of g, what do you look at when you look for points of inflection? Well, do you look at the first or second derivative? Second derivative. So what I'm going to do is make a number line chart for g double prime. Going from negative 2 to 5. wherever G double prime switches signs, I'll expect that those are going to be points of inflection. The only way they wouldn't be is if a tangent line doesn't exist at those points. Like if there was a cusp or a corner or something like that on the graph of G. So we're going from -2 to 5. Now, we said earlier that G prime equals f of x. Okay? So if G prime equals f of x, G double prime would equal what? F prime of x, which would also be interpreted as the slope of f of x. So to get G double prime, we're going to look at the slope of the f graph. So I go up here, here's my f of x graph, I want to look at the slope. From -2 to 0, what do you think the slope is right there? Positive, right? At 0, I'd say the slope is 0. From 0 to 2, what does it look like the slope is right here? Negative. How about at 2? It looks like there's a corner there. What would you say the slope is right there? Undefined, yep. Then from 2 to 3, still negative slope. How about from 3 to 5? Positive. How about at 3? I missed that. There's a corner there, so undefined slope of G of F, so G double prime is undefined. So what this is telling me is that the original graph of G of X is going to go concave up between -2 and 0, then concave down from 0 to 2, concave down again from 2 to 3, and then concave up from 3 to 5. So it looks to me like there's going to be points of inflection where G double prime switches signs. So points of inflection at x equal, what would be the first one? 0. And also x equal 3.
Did you say though if the slope's undefined, it's not a point of inflection?
Right, if the slope of G was undefined. Okay? So, well, it still could be a point of inflection. If a tangent line doesn't exist. If you saw a jump, you would see a jump in the y-coordinate here. That would mean a jump in the slope of G, which means G would have a corner on it. There are no jumps in this graph. There's no jump discontinuities here, where the graph makes a sudden switch from a y-coordinate of, say, 2 to -2 or something. I mean, I realize like at 3, there's a corner there, but look at the y-coordinate. The y-coordinate slowly goes towards -1, and it slowly goes away from -1. So the slope of G slowly goes towards -1, then it slowly goes away from -1. There's not going to be like a big jump in the graph of G there. Or there's not going to be there's a corner on the G prime graph, but there would not be a corner on the G graph, because of the fact that the slope gradually, the y-coordinate, which is the slope of G, goes towards -1, then goes away from -1. It doesn't jump from -1 up to here all of a sudden. Okay? So both of these would be points of inflection. Any other questions about that? Okay. We got about 12 minutes. Go ahead and work on whatever.